Use quantifiers to make each of the following true, where n is a natural number. So let's take a look at these questions here. So for A, if we wanted to solve for this problem, we would subtract 5 to both sides. So if we subtract 5 to both sides, we would get n, which is equal to 20 minus 5, which is 15. And therefore, 15 is a natural number. Okay, so if we come back to our result here, we should see that there exists a natural number n such that n plus 5 is equal to 20. Now let's take a look at part B, n squared equals 16. So if I have n squared equals 16, this is the same thing as you would take the square root of both sides to solve for n. Now, if you take the square root of both sides, that means you're taking plus or minus the square root of 16. Therefore, n can either equal positive 8 or negative 8. Positive 8 is a natural number. Now, negative 8 is not, but because there is a natural number here, we would say that there does exist a natural number that we can solve here. So therefore, we would say the following. We would say that there exists a natural number n such that n squared is equal to 16. Okay, now let's take a look at the next one. N plus 6 equals 6 plus n. Okay, so if we subtract 6 to both sides, then we get a true statement where n is equal to n. If that means that this is a true statement, that means we can choose any value for n and it's going to equal the same thing. And that would always make it true. And so therefore, we would say the following. We would say that for all natural numbers n plus 6 equals 6 plus n. Now let's take a look at D. So here, if we combine like terms, we get 6n, which is equal to 6n. And similarly, it's the same thing as part C. Now, if we divided both sides by 6, okay, we would get the following. N is equal to n, which is the same statement that we have for C. And therefore, we would say the following, that for all natural numbers n, 4n plus 2n would equal 6n.